Morning viewers, my names are Joseph Opati, a math teacher in Boqol Academy. I want to welcome you to this lesson of today where we have a continuation of our quadratics topic. I want to appreciate those who have been able to view the other clip and those who have been able to give good comments. And of course, I was encouraged now to do my best and clear the remaining part. So we'll continue the same and hope we cover some good ground. So in our last lesson, we talked about what? Quadratics expression and differentiated an expression from an equation. Now today, we'll pick from where we left from. Of course, we covered the issue of what? Expansion, which was the removal of brackets. So today we discuss the issue of quadratic identities. So quadratic identity. Now, to begin with, we must be able to understand what the term identity means. Now, an identity is simply an equation which will always hold regardless of the changes in the values of the variable in that equation. By holding, I mean the equation will always be true. Of course, we have what we call what? A false and true equation. If I have 3 plus 4 is equal to 7, we call this a true equation. Why? Whatever is on this side is actually equal to whatever is on the other side. But the moment I have 3 plus 4 is equal to 6, of course, we know that 3 plus 4 is not equal to 6. Therefore, I should put that symbol to mean what? 3 plus 4 is not equal to 6. So, when you have 3 plus 4 is equal to 6, given the fact that whatever I have here is not equal to whatever I have there, we call it what? A false equation. So we are saying for an identity, it must be something which gives us what? A true equation, regardless of the what? The changes in the values of the variable in that equation. So I'm going to give an example of an identity and then we shall come back to what? Quadratic identities. Now, if I have x plus y is equal to y plus x, this is a good example of an identity. Why are we saying that? Now, if I take x values, the x value to be 4 and the y value to be 3, and then make my substitution in that equation will be satisfied. The equation will be true. Now let's confirm that x is given by 4, y is given by 3, is equal to y is 3, and of course x is 4. So on the left hand side we have 4 plus 3 to give me what? 7. On the right hand side we have 3 plus 4 to give us 7. Now this equation is a true equation. Now what if we are able to change the values of x and y? Will the equation still hold? Let's confirm that. If at all I change x to be 6 and I change the value of y to be 4 and then make my substitution in the same equation that we had originally here. We are saying x is 6 I will have 6 plus y given by 4 is equal to y, which is 4 plus 6. Now what do we have? We have 10 is equal to 10. Of course, the equation still holds, meaning is a true equation. Remember, I use a combination of 4 and 3 here. Here, I change the values, but now, whether we use 4 and 3 or 6 and 4, the equation ends up to be what? A true equation. Therefore, we are saying whatever we have here is what? An identity. Are we together? Now, we want to give another example of how we can further our understanding of what? The term identity. Now, if at all I have x times y is equal to y times x, then I have what? X given as what? 4 and y given as what? 3. We are saying in this case, if I make my substitution, what will I have? 4 times 3 is equal to 3 times 4. Here we end up with what? An equation that holds, meaning a true equation. Why? Whatever we have on the left hand side equals whatever we have in the right hand side. We continue. Now, I choose a different combination of the x and y value. Let's choose x to be 5 and y to be 6, and then make our substitution in that equation. The value of x is 5. I have 5 times y given by 6 equals to y value 6 times the x value, which is 5. I end up with what? 30 equals to 30, meaning the equation holds. Therefore, this is another example of an identity. Regardless of the combination of the values of x and y, we are saying the equation still holds. The equation is satisfied. Now, we look at our third and possibly last example to confirm what an identity is. Now, if I have this x minus y is equal to y minus x. Or let me choose an example that will work well. Let me have x times y is equal to the square root of x times y. I think this will work well, just to make sure the point is home. Let me choose the values of x to be initially 1 and y to be 1. In this case, when you make your substitution, 1 times 1 is equal to what? 1 times 1. What do you end up with? 1 is equal to 1. We are saying the equation still holds. But what about if we change the combination of the x and the y value? Will the equation still hold? Let's prove that. Let me choose x as what? 2 and y as 3. Then we have, of course, 2 times 3 is equal to what? Square root of 2 times 3. What do we get? 6 is equal to square root of 6. I think we all agree that in this case, whatever I have on this side is not equal to whatever I have on this side. Now, meaning for this case, we cannot call this what? an identity. For any equation to be called identity, at any time, if at all you change the values of the variables, the equation must still hold. Now, having discussed what an identity is and given, of course, several examples, now we can go to what? Quadratic identities. Now, there are 3 quadratic identities. There are 3 quadratic identities. The first, given by x plus y squared is equal to x squared plus 2xy plus y squared. And the second being given by x minus y squared is equal to x squared plus 2xy plus y squared. And the third being given by x plus y times x minus y is equal to x squared minus y squared. So for this equation, regardless of the combination of different values in terms of x and y, the equation will always be satisfied. The equation will always hold. But let me just quickly explain how you can be able to remember them. We begin with the first, of course, identity given by x plus y squared is equal to x squared plus 2xy plus y squared. Now, how can we remember that? Very, very simple. So, we are discussing the first identity given by x plus y, of course, squared, which will give you that. So you're saying whenever you have such an expansion, your outcome will have 3 terms. The first term, the second term, and we can say our third term there. So how do we get the first term? The first term in the outcome of this expansion, which is x squared, is found by taking the first term in the bracket on the left hand side and squaring it. Then our third term in the outcome is normally found by doing what? Taking that second term in the bracket which is in the left hand side and squaring it. Then the middle term, how do you get it? You take 2, which is a constant, times whatever elements or terms you have in the bracket. In this case, what do you have? We have x and y. So, an example, you are told to expand x plus, let me do it from this point. You are told to expand x plus 4, of course, using the quadratic identity. Now, before I use the quadratic identity, we are going to use it to expand it using, of course, the long multiplication. So, x plus 4 squared means x plus 4 times itself twice. So we have x plus 4 times x plus 4. Now that will mean, from the previous lesson we discussed how you go about such an expansion. It will mean you take x, the first term in the first bracket, times the entire second bracket, plus 4 times again the entire second bracket. How do you proceed? Of course, now you do away with the brackets now completely. X times x will give you x squared. X by 4 will give you 4x. Then 4 by x will give you 4x. Then we have 4 by 4 to give you 16. Now, at this level, to complete your expansion, you put like terms together. We have insisted like terms means what? Terms having the same composition, the same letter composition raised the same power. So we have like terms in the name of 4x and 4x. Now, our eventual answer becomes what? 8x plus 16. So we have x squared plus 8x plus 16. So just recall somewhere in your mind that that was our outcome. Now the question is, how can you obtain the same outcome using the concept of quadratic identity? Of course, not to be specific, the first quadratic identity. That is achieved in the following manner. So I want to achieve the same outcome using the quadratic identity. X plus y squared is equal to x squared plus 2xy plus y squared. We are saying from this rule, an expansion of this nature will have 1, 2, 3 terms. So how do you get your first term? You consider the first term under what? That bracket. Inside that bracket. In this case, our first term is x. And you do what? You square it. Plus, how do you get your middle term? You take 2, which is a constant, times. I will put here a dot to mean what? Times. Just to avoid confusion with the x. So 2 dot to mean what? 2 times. Then whatever you have in the brackets. So 2 times x times 4. And then plus our third term, y squared. How do you get it? You square the second term in our bracket. Our second term here is what? Is 4. So you say what? You have 4 squared. So what do you end up with? X squared plus 2 times x gives you 2x. 2x times 4, you get what? 8x. Then square the 4 to give you what? 16. If you are keen, we have what? The same outcome as we got earlier using what? The long, of course, multiplication approach. So we are saying the identity actually makes the work easier. If you are keen, in the other expansion of the same, we went through several steps. Here, only 2 steps are able to give us the same outcome. Now let's do more examples just to confirm we are okay in terms of that first identity. Now we can now wrap that and be able to do more examples. Now if you are given, let me call it example 2. You are given x plus 6 squared, and then you are required to use the quadratic identity, which is the first identity. Of course, we have copied it. By now, we are saying it will be an outcome which will have three terms. The first term, I square the first term in the bracket. That will be x squared. The second term, you take 2, which is a constant, times that first term x times that second term x, then the square of the second term in the bracket. So what do we end up with? We end up with x squared plus 12x plus 36. That's what we get. So having understood that, we can do now a number of questions. So we have a question here. You are told to do what? Expand the following. So we have Roman 1 x plus 7 squared. Roman 2, now I'll change them a little bit. We have 2x plus 5 squared. Roman 3, we have 2x plus 3y squared. And maybe Roman 4, we have 2x power 3 plus, let's have maybe 5y squared. So how do you go about expanding this? Using that first quadratic identity. We are saying whatever steps we have outlined are the steps to be undertaken. So what will we get there? We square the first term in the bracket on our left hand side to give us what? X squared. Then we take the 2, which is a constant, times the content in terms of the terms in the first, in the bracket in the left hand side, which we have x and also 7 plus the square of our second term in that bracket. So what do we get? We get x squared plus 14x plus 49. We are done with the first expansion, of course using what? The quadratic identity. Now we continue, we go to, of course that was 1, we go to number 2. Number 2 given by 2x plus 5 squared. Again, we want to achieve that the outcome of that expansion basically in 2 steps. So what do we have? We shall have 2x, in this case being the first term in our left hand side bracket. So we do what? We square the 2 plus 2, which is a constant, times the 2x times 5 plus the square of the second term in this bracket. Now what do we end up with? 4x squared. Remember, the power 2 here will affect both 2 and the x, plus 2 by 2 by 5, you get 20x plus 25. Sorry, that becomes the outcome of our second expansion. Now, having done the first 2, we can just create more space there and be able to cover our third, of course, expansion. Our third is 2x plus 3y squared. Again, the similar steps are undertaken. So the first term here is 2x. We have it squared. Then we have 2, which is a constant, times whatever terms we have in our bracket. Remember, there are only 2. That is 2x and 3y. So 2 dot 2x dot 3y plus the square of 3y. So what's our final outcome? The outcome will be 4x squared. Of course, the 2 affecting both 2 and x, plus 2 times 2x times 3y. If you are keen, the outcome will be 12xy. Then lastly, what we have? 9y squared. That becomes the final outcome. Now we have our last expansion in terms of the what? The first quadratic identity. Now here what we have? We have 2x cubed plus 5y squared. We want to get that expansion achieved in 2 steps like the previous ones. So again, we have 2 terms. 2x cubed is a single term, being the first term. 5y squared is the second term. So we have the square of the first term plus 2, the constant, then times the terms in the brackets. Just create some more space there. So 2 times 2x cubed times 5y squared plus the square of our, of course, second term in this bracket. So in the end, what do you get? 4x power 6. Applying the lots of indices, you get that, plus 2 by 2 by 5. That coefficient of the x term and the y term will be, of course, 20. Then x cubed y squared plus 25 y squared, and we are done. So just to give you a few questions for your practice based on that first quadratic identity, to see if at all you have mastered that. So I'll give some questions here for your practice. So try expanding the following using what? Of course, the first quadratic identity. The question is expand so I'm saying try and use what? The quadratic identities. So the first can be 3x, that's 4y squared. See what you can get. Then we have 5x power 4 plus 2, let me have 2y cubed squared. And maybe the last question, try expand this. Let me have 5xy squared, a bit tricky, plus 2t squared. So try expand that just to confirm you are okay with the concept we have covered. So we're done with that. We go to quadratic identity number 2. So quadratic identity number 2. I just hope you're done with that. Okay. Now, the second quadratic identity was given by x plus y, should have been actually is x minus y squared is equal to what? X minus 2xy plus y squared. If you're keen, the outcome is similar to the one of the first quadratic identity with one difference. We have a minus here. So again, having taken enough time to cover the first one, I'll just take what? A short time to cover this. Now, you are given such an expansion as x minus 4 squared. Now, how do you carry out this expansion? You have two options. The first option will be to use the long multiplication, something we want to do it here. Let's have that done quickly. This implies is x minus 4 multiplied by itself twice. That means I'll have x into what? X minus 4, meaning x times the entire second bracket, then minus 4 times again the entire second bracket. So what do you get? X by x gives you x squared. X by that gives you minus 4x. Negative 4 by x gives you, of course, that. This negative by that will give us that outcome of plus 16. Then these are the like terms. What do we end up with? X squared minus 8x plus 16. That becomes our eventual answer or outcome. Now we are insisting we have how many steps here? 1, 2, 3, 4 steps. We can arrive at the same outcome, of course, taking minimal steps by using what? The quadratic identity. X minus y squared is equal to x squared minus 2xy plus y squared. How can we achieve that? Very simple. Having done the first one, this should not be a challenge. We are saying the first term of our outcome, we consider the first term in the bracket, of course, which is x, then square that. Then we have a minus 2 times those terms in the bracket, that is x and 4. Then plus the square of 4. So what do you end up with? You end up with x squared minus 8x plus 16. Virtually, of course, the same outcome. So we are saying quadratic identities are meant to make our work easy. The equation is always going to hold irregardless of the values you have been given. Just maybe one or more 2 examples, then we go to our third quadratic identity. Now, assuming you have been given this 2x minus 4y, let me have it as 4y squared. So what will be the outcome? The outcome will be, of course, now again achieved in 2 steps. So we take 2x, square it, minus the constant 2 times the first term in that bracket times, of course, the second term in that bracket plus the square of our second term given by 4y squared. So what is the outcome? 4x squared minus 2 by 2 by 4 will give us what? That will give us 16x y squared, and then plus 16y to the power of 4. We're done with that. So I'm saying it is similar to what? The first quadratic identity with one difference. What is the difference? We have a minus in our second term. So we are done with that. We go to our last. Of course, let me give some questions just for you to attempt. Then we go to our last identity, and possibly we shall be able to see how in the past these questions have been tested in the KCSE exam. So a question for you. This is a question for you. In terms of that, we have expand of course the following. Remember expression, because now expand, when you hear expand, simplify factors, in most cases your focus should be I'm dealing with what? A quadratic expression. So let's have this just for your practice. Expand that and see if at all you are comfortable with that. We can have 4 minus 2y squared, and possibly the last one, let's have 5y minus 3x power 4 squared. So try expand those ones. Those ones will be like a homework. Let me try and get now some questions, but we're yet to cover one more, of course, quadratic identity. Then we shall see how in the past these questions have been tested in the KCSE exam. So let me quickly guess the question just to be ready. Once I cover the third one, we straight away go to what? Go to covering, of course. Okay, the third identity, the third and the last identity, we have said it is given by what? X plus y times x minus y. That gives you x squared minus what? X squared minus y squared. So how are you able to recall this quadratic identity? If you're very keen, the elements in this bracket and that bracket are the same. We have x, we have x, we have y, we have y. The only difference is that we have a plus here and we have a minus here. So what do you call this? We call this sum, and we call that difference. So sum times difference will give you what? Will give you the difference of the squares. So the square of x is x squared, square of y is y squared. So I must insist this is a quadratic identity that is commonly tested in many examinations. So make sure you master this. So of course I'm going to do my best to make sure you get everything right. Let's look at few examples just to make sure we get the point. We have x plus 4 times x minus 4. So using the long multiplication, what will be the outcome? Using the long multiplication, we are saying we shall have x, which is the first term of the first bracket, times the entire second bracket, plus 4 times again the entire second bracket x minus 4. So what do we get? We get x squared minus 4x plus 4x. If you're very keen, x by x gives you what? X squared. X by that minus 4x. 4 by x, 4x, which will be a plus. Then this by that, we have a positive, negative. You get minus 16. Then this and that will give us what? A 0. What do you end up with? X squared minus 16. So you're saying this is the third and last identity. So just two examples, and of course now we wind up with what? The quadratic identities. So we are saying the same outcome can simply be achieved by doing what? By just saying, taking the x, which is the first term, squaring it, minus the square of what? The second term. In the end, what do you end up with? X squared minus 16. So quickly, just some 2 or 3 examples, and we are done with today's lesson. And this will be lesson 2. So maybe lesson 3 will go to discuss other aspects of these topics, including algebraic fractions, including quadratic equations. So quickly, let me summarize that. So given, now recall, that's what we had as our third identity. We had that. So having x plus 3 minus x plus 3, what will be the outcome? The outcome will be x squared minus 3 squared to give us what? X squared minus 9. What if I had 2x plus 3, then 2x minus 3, of course being multiplied. Now from that format, I will take what? The first term, have it squared, minus the second term, have it squared, to give us what? 4x squared minus 9. Then our last example, we have 4x, let's say, minus 5y squared. Then again 4x minus 5y, this should be a plus 5y squared. So what will you get? We shall get 4x squared minus 5y squared. In the end, we have 16x squared minus the square of 5y squared, which will be 25y power 4. So by that, we come to the end of our lesson. So remember, identities are simply equations which will always be what? True, which will always be satisfied or will hold regardless of the values of the variables put there. So we are done. Let's pick from there next time.